Now let's prove that the sum of cotangent functions is equal to 1. We need to prove the equation. So the question states that alpha plus beta plus gamma is equal to 180 degrees, right? And so basically these are the three angles of a triangle. And it says that cotangent alpha, cotangent beta plus cotangent beta, cotangent gamma plus cotangent gamma, cotangent alpha is equal to 1. And we need to prove it. Okay. So the first thing that is given to us is that alpha plus beta plus gamma is equal to 180 degrees. Fair enough. Now, once you take the gamma to the right hand side, it becomes negative gamma. So you have this. So alpha plus beta is equal to 180 minus gamma. Now apply the tangent function on the left hand side and the right hand side. So you end up with this. Fairly simple. And now use the trigonometric identity, which states that tan alpha plus beta is equal to tan alpha plus tan beta over 1 minus tan alpha tan beta. And you apply the same property over here and you end up with negative tan gamma. Why? Because tan, this can be written down as tan 180 plus tangent, sorry, not plus, negative, because this is negative, right? So minus tangent gamma. I'm sorry for my drawing, it's just a little bit off. Okay, over 1 plus, not minus, because again it's not a positive sign, it's a negative sign between 180 and a gamma. So 1 plus tangent of 180, oops, sorry, tangent of 180 into tangent of gamma. Okay, now tangent 180 is equal to 0. Okay, we already know that that's equal to 0. So eventually you just end up with negative, this becomes 0, you cancel it out, and again since this is 0, this entire term tan 180 into tan gamma is also equal to 0. So you just end up with negative tan gamma, which is why you have it over here. Okay, now that we've established that, you now take the reciprocal of all the tans over here and you get the cot functions. Why? Because we're dealing with the cotangent function in the question itself. So you convert every tan function into cotangent by taking the reciprocal. So tan alpha becomes 1 over cotangent alpha, tan beta becomes 1 over cotangent beta, and that's the same over here as well and here as well. And similarly, this tan gamma becomes 1 over cotangent gamma. Fair enough. So you have this. And now, once you take the LCM in the denominator and the numerator, you get this, right? And now that you have this, again, this happens because if you take the LCM over here in the numerator, you basically multiply this with cotangent beta and the denominator with cotangent beta as well. And so you have in over here, let me just write this down. So this becomes basically cotangent beta plus cotangent alpha over cotangent alpha cotangent beta. And this entire thing is now divided by 1 minus whatever this is. And when you take the LCM of this over here, what do you get? Well, 1 will be multiplied with cotangent alpha cotangent beta. So it becomes cotangent alpha cotangent beta minus 1 over cotangent alpha cotangent beta, right? And now this and this can be cancelled out and you're eventually left with this. Fair enough. So now that you have this, what you do is you cross multiply, right? Cross multiply this and cross multiply this. So you get this cotangent gamma into cotangent alpha plus cotangent beta is equal to negative cotangent alpha cotangent beta minus 1. Okay. Now you multiply and expand. So this becomes cotangent alpha cotangent gamma plus cotangent beta cotangent gamma is equal to negative cotangent alpha cotangent beta plus, because this negative and this negative multiply, so plus 1. Okay. And now when you take this term cotangent alpha, cotangent beta, this negative cotangent alpha, cotangent beta, to the left-hand side, you eventually prove the question itself. And that's what we had to do.